Welcome to our discussion on special applications of percent calculations. In this video, we're going to look at some very specific applications of percentages that come up in word problems, such as something that's been discounted, where you have to take into consider what is the sales tax or kind of solve backwards for a price that already has sales tax added to it, dealing with interest on a purchase, commission rates, efficiency rates, tolerances, and basically percent change. All of these things boil down to versions of a percent change problem. And so we can come up with a generalized kind of recipe technique for solving all of these. So we don't have to think of, oh my gosh, I got to come up with 7 different ways to do these things. Nope, there's just one that does them all. Okay, so a very common type of percentage question involves the idea of a discount. So, i.e. marking down a price. So you've got the list price or the original price, and then you've got the net price or the new price. And basically the new price just equals the original price minus the discount. Or in this case, if you want to use these vocabulary terms, the net price equals the list price minus the discount. So just think new price equals original price minus discount. Now the discount rate is a percentage number that enables you to calculate this discount as part of the list price. So the percent proportion, the way we can set it up is the part over the base equals the rate over the 100, right? We've done this before, and it becomes, oh God, I hate. All right, so the discount rate. This is how a lot of sources, books and classes and whatnot like to present this material. And it gets so confusing for students. They get so bogged down in all the letters and all this jargon that it just seems so much more difficult than it is, right? Okay, the discount rate and the percent number and, the part and the base and the rate and blah, 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 blah. Don't overthink it. They're making this thing so much harder than it is. Your discount is, in a pure sense, the discount is just the difference in the two prices. We already talked about how the new price, right, equals the original price minus your discount. Or, if you want to think of it the other way, the discount simply equals the original price, right, minus the new price. If we added discount over here and subtracted new price over here, we get this same thing. And that makes sense, right? If our shirt started at $40 and then they discounted it down to $30, well, didn't we just take $10 off, right? The discount is the original price of $40 minus the new price of $30. That's a discount of $10. So if you want to figure out the actual, what we call like the pure amount of the discount, it's simple. Old price minus new price, right? Original price minus new price, however you want to think about it. Now, if you want to think of what's the discount as a rate, right? What is the percentage that we took off, right? So sure, we took off $10, but what is that in terms of a percentage? Well, that's really simple because what we call, all of these are going to come down to percent change. The delta means change, and so this is just shorthand for change. A percentage change really just is always calculated as the difference, i.e. the change, over the original, the starting point. Think of it as the starting point. So in the case of this one, our difference was $10 because it went down by $10. It started at 40. That's 1/4. Slap that into your calculator. That's 0.25 or 25%. It's that simple. So the discount rate in that case was 25%. And we don't have to deal with any of this junk. So let's just simplify our lives and realize that when we're dealing with any kind of percent change problem, and a discount is a percent change, we're asking by what percentage did the price change, right? Did it get discounted? Then that's simply difference over original or difference over starting point. Okay, let's take what we've previously learned about translation of simply, what is what percent of what, right? We'll have two of those three things we need to solve for the missing, right? Either we don't have the triangle, we don't have the square, we don't have the circle. That's easy. As long as we have two of the three, we can solve it, right? So simple translation. And then we can add in the idea that percent change is simply our difference over our start, our original value or our starting point. And between those two things, we can solve just about everything. Now, if we add one more simple concept, it's going to make our lives so easy that everything can be done the same way. And that is that a percent increase really just equals 100 plus whatever that increase is. And then that becomes a percent of, which makes the math easier. And same thing, a percent decrease is just going to be 100 minus whatever that decrease is. And then that turns the question into, again, a percent of, where we just do multiplication. And we'll do a couple examples of those later on to show you what I mean. But basically, everything's going to, we're going to find out that it's going to be so easy to do everything with this simple idea. So for instance, with this question, it says the list price of a tool is $18.50. On a special sale, it is offered at 20% off. What is the net price? Okay, well, we can figure out, what is 20% of $18.50? And that's going to give us the discount. So we can do that math and figure out what the markdown is. So we slap into our calculators, right? 20 times 18.5 divided by 100, or we can get to the point where we go, this is just 0.2, right? So we can do 18.5 times 0.2 in our calculator and get 370. So that's what the discount is. Then we can subtract that from 18.50 and get 14.80. Well, if we want to save ourselves that second step of doing subtraction, all we have to do is realize that 100% is the whole, right? It's the whole pie. And if we're taking away something, right, we're taking a little slice out that's our discount, then the leftover piece of the pie has to make up the rest of the stuff that gets us back to all 100%. So for instance, if we take 20% away from something, we've left 80% behind, right? If we take 15% away from something, we leave 85% of it behind. So with that previous question where they told us we were taking 20% off of the price and they wanted to know what the new price is, well, that's easy. It's just going to be 80% of what it started at. So we started with, right, $18.50, and then we multiply that by 80%, because if we take 20% away, we're going to have 80% left over, right? This is the 20% discount. This is the 80% that's still there. So you simply just take 18.5, multiply it by 0.8, right? Or multiply by 80, divide by 100 if you're not there yet. And you get, lo and behold, the same answer we got before of 1480. And it saves us the step of having to subtract. So if you can wrap your head around the idea, the concept of if we take a certain percentage away, what percentage are we left with? Then it turns everything into a percent of. And when we do percent of, that's just simple multiplication, right? So it gets us back to what percent of this is that, right? Or this is what percent of it, right? Gets us back to that simple translation question. So the basic idea is whenever you're doing a discount problem, instead of figuring out what the discount is and then subtracting it from, just come up with your new percentage rate as being 100 minus the discount, and then that goes straight into the multiplication. Let's look at another example. After a 25% discount, the new net price of a 5-inch random orbit sander is $57. And the question is, well, what was its original price? What was the list price before the discount? Well, again, we take 25% off. That means we're left with 75%, which means that this price represents 75% of the whole, i.e., $57 is 75% of the original list price. Well, that's easy, right? If we want to, 57 equals 0.75 L. If we want to solve for L, we just divide by 0.75. So we get 57 divided by 0.75. And lo and behold, we get that the list price is, or was, $76. Now you can double check it. Take 25% of 76 if you want, right? 76 times 0.25, that gives you $19, right? And if we subtract $19 from it, lo and behold, we get back to 57. So we didn't mess anything up. Let's look at another example. A kitchen sink that retails for $884 is offered to a plumbing contractor for $574.60. What discount rate is the contractor getting? Well, first we need to figure out what the actual absolute discount was in dollars and cents, right? The pure amount, not as a percentage, but just how much of a pure amount. And that's simply the original, right, minus the new, right? So old minus new gives us the difference, the discount. So they were saving a little over $309, right? $309.40. Now, most sources are going to keep going back to this whole ratio idea of discount over original equals rate. Well, that's my ratio that I talk about difference over start or original, right? Same thing as D over L, just D over S is going to equal your percent change. And when you do R over 100, that's a percent. So when you see funny things like that, they're just telling you the same thing I've already told you. Here's my difference. Here's the original price of $884. That's going to equal some percentage, right? Something over 100. We can solve for R by multiplying by 884 to bring this over here. Then multiply both sides by 100 to get rid of that, which basically just moves the decimal place. So that's how we get to this place here. Then divide them both by 884, and we get 35, which is a 35%. It's just that simple. What about if we have multiple discounts? And this happens all the time, right? Where something will be discounted, then discounted again, and then discounted again. The biggest mistake students make is they think you can add discounts together, and that does not work at all. So for instance, a washing machine started at $740. The buyer obtains trade discounts of 30% and then 10% and then plus a cash discount of 3%. They don't add those all together and go, we're just going to take 43% off of your washing machine. It doesn't work that way. Unless, they specifically say they're going to add up their percentages. What normally happens is first they take 30% off the price. Then they apply another 10% discount to the price. Then they apply the third discount of 3%, right? So it's a discount on top of a discount on top of a discount. And so that doesn't add up that way. And an easy way to prove that to you, just to visualize that, is let's say you start with $100, right? And you're going to take 10% off twice. So first you take 10% off, and that's really easy. 10% of 100 is 10. So now you go down to 90. Now you take 10% of this off. Well, 10% of 90 is $9, right? So you take $9 away, and it goes to 81. If you took the 10% and added the other 10% to it and simply took 20% off of this, you would take $20 off, and the price would be 80. And even though it's a small difference, it's still a difference. It means it's wrong. You can't do it that way, right? So you can see how adding the percentages together and then taking one percentage of the original thing is going to give you a different result than if you stack the percentages. Take the first one, then take the percentage off of what's left, then take the percentage off of what's left, and so on and so on and so forth. So that's really what you have to do. So if we're going to take 30% off, remember that it's much easier to, instead of multiplying it by 30%, figuring out what that is and subtracting, we can just figure out what's left behind, and what's left behind is 70%. So we can just take 70% of 740 and get 518. And now we can repeat the process. We're taking 10% off, which means we're left with 90%. So we're going to do 90% of the previous, right? The intermediate of 518 after we had the first reduction. And that's going to equal what we get with that one, which is 466.20. And then finally, we're going to take that 3% away. But remember, 3% away means 97% is left behind. So we can simply just turn it into 97, and I'm going to do it as decimal, right? 97% of, we're going to multiply that, 466.20 is going to equal our final amount of 452.21 if we round to the nearest penny. Now, instead of doing each of those steps individually, you can realize that what happened is we started with an amount of money, we multiplied it by 70% to take the 30 away, and this is what gave us the 518. Then we took 518 and we just multiplied it by 0.9, right, to take the 10% away. And this is how we got down to 466.20. And then finally we multiplied that by 0.97%, and that got us to our final answer. Yay, we're finally there. So instead of doing those intermediate steps, we can just start with the original and multiply it by each of those remaining, right? So by multiplying by 70, we're basically kind of multiplying it by each of the reductions. And that's what we're illustrating here, that in our calculator, we could just start with the original price of $7.40, multiply it by 70 over 100, or 0.7, then by 0.9, then by 0.97, and get the final answer quick and painlessly and not have to do all those intermediate steps. So just remember that if you have to do percentages on top of percentages on top of percentages, you don't add them, you multiply them, because you're applying the new percentage to what was left over, right? So you just keep multiplying to get down to your final answer. So as I've already mentioned, and hopefully you're starting to get comfortable with it, is the idea that it's much quicker to deal with percentages if we simply change the percentage to a decimal number and then multiply our number by that, i.e. the base, right? The base number is your amount. So instead of taking something times 25 over and then dividing by 100, we can just do something times 0.25. It's going to make your life a lot simpler once you get comfortable with that. So for instance, right, 20% of 640, well, remember, it's 20% of 640 is going to equal something, but we can now think of this as 0.2 of 640, and all we're doing is taking 640 and multiplying it by 0.2. Okay, sales tax is another kind of percentage problem that is tackled the same way, right? If you have to calculate what sales tax is or add sales tax and blah, 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 it's all about percentages. Well, sales tax is basically just the percentage of the stuff, right? So we can always set it up as this ratio that, let's say we look at our bill and we paid $7 in sales tax, and we had a list price of, $35. So $7 over $35 will tell us what that tax rate is. So this is the proportion that we're setting up. But it still goes back to, what percent of that $35 is the $7 that we paid in sales tax. Okay, well, to solve for x, we divide both sides by 35. So we get x over 100 equals 7 over 35. And then, of course, to solve for x, you would multiply by 100, because that's just to get it as a percentage instead of a decimal. Well, look at what this is. Here's sales tax over list price. Here's sales tax over list price equals tax rate over 100, right? So these funny little proportions they keep throwing at you, they really just come from our simple translation of something times something equals something, right? Of is multiplication, is equals, and what we're looking for is always Rx. Okay, let's apply it to a simple example. If the retail sales tax rate is 7.75% in a certain city, how much would you pay for a digital multimeter with a list price of $76.50? Well, we can figure out what the sales tax is by simply taking 7.75% of 7650. So we don't have to deal with all this stuff, and we can finally just come down here and go 7650 times 7.75%, which is really times 0.0775, right? Because we divide both sides by 100. And we get $5.93 is how much sales tax we would pay. What if we just wanted to know how much we're actually going to pay for the item, right? We don't care how much the sales tax is. We care what the total price is. Well, just like before when we had those pies, right? And we knew that we've got the total, and here's my discount, and if I take this, then we can look for what's left over. Well, when we're adding a sales tax to it, we're really now getting the whole pie plus a little bit more. So if we're adding 7.75%, that means we have 107.75% of what we started with. We have the entire whole amount, we have the entire pie, and then we have to add 7.7%. So basically a shortcut is always going to be 100 plus the tax, or think of it in general, the added amount, right? If you're adding any kind of percent, so they say, increase the output of your circuit by 20%. Well, that means the new amount is going to be 120% of what it used to be because we added that 20% to 100. So just like when we reduce something, when we discount something, we subtract that amount from 100. When we're adding something, then we just add that amount to 100, and it makes the math so much easier because now we could just do 76.5 times 1.0775, right? Because as a percentage, it's 107.75 as a percent, but we don't deal with percentages. We don't multiply by percentages. We don't divide by percentages. We have to do their decimal equivalent. And remember, the decimal equivalent of a percent is to move the decimal 2 places to the left. So in this case, it's 1 point something. It's bigger than 1, which makes sense because the percentage was bigger than 100%. So you do that math, and you get $82.43 when you round to the nearest penny, which you can double check is what you would get if you do 76.50 and add 5.93 to it. So it's just a little shortcut when we realize we can just add our percentages to 100, convert that to a decimal, and do some simple multiplication. And so here's what that would look like if we wanted to put it back in those proportional things, right? Here's my 100 plus my tax rate. But remember, it doesn't have to be just tax, any kind of percent increase. So that's what happens when we do a percent increase. We've already seen what happens when we do a percent decrease. Well, that brings us back to percent change, which we already talked about at the beginning of the video. We can formalize it here, that to figure out percent change, we just take that amount of increase or decrease, divide it by the original amount, and that's going to equal our percent increase or decrease over 100. It's really just that simple. So for instance, suppose that the output of a certain electrical circuit is 20 amps, and the output increases by 10%. What's going to be the new value of the output? Well, we can set it up, right? The amount of increase over the original amount is going to equal the percent increase. The amount of increase we don't know. 20 is what it was. Goes by 10. We can do some math, multiply both sides by 100, right? Then divide by 10, and we get 2. Which I'm sure you were all just going, come on. I know that if I increase something by 10%, I literally just take 10% of 20. So 20 times 10% and get 2. We don't always have to set up things with these silly little proportions. It's just when the math is more complex. So this is going to formalize what we were talking about when we're adding sales tax. It's really just adding that increase, and it doesn't matter if it's sales tax or whatever. We can always just set it up as 100 plus whatever it is. That's going to be our new amount, and then we can multiply like normal. And conversely, if we're doing decreases, we don't have to do all of this stuff and do these intermediate steps, right? If we're going to decrease something by 8%, instead of doing all of this, we know that if we take 8% away, we're left with 92%, and all we have to do is take the original amount and multiply it by 92%, i.e. 600 times 0.92, and get straight to 552, saving us some time because we know that when we take something away, it's just 100 minus that amount to figure out what's left over, and then that becomes an of. So that's it, guys. Percent increase, we're just going to do 100 plus the amount and then multiply by that decimal. Percent decrease, we're going to do 100 minus that amount and multiply by that decimal. And we're always going to remember that our simple translation of is equals, of is multiplication, and percent is divisible by 100. Whenever we want to deal with percentages, we have to remember that we have to always convert them into decimals, sometimes a whole number right with a decimal, but that's the basics, and that's all I've got for you.